So page 171, first of all, we want to talk about this thing called inverse variation. Inverse variation. So inverse, as one concept, I'll get it later, I'm not going to answer it right now. As one, sure, just so you know, Mr. Davies is teaching. Go ahead and answer it, yeah.
Cascade High School student speaking. Mr. Davies is teaching right now. All right.
What do you know?
They hung up on me.
Good enough. Obviously, it wasn't worth my time. So look at this graph. As one x values gets bigger and bigger and bigger, the y value gets smaller. Can you see that? My x values are getting bigger and bigger and bigger as my y values get smaller, right? Or as my x values get smaller and smaller and smaller, my y values get bigger. That's like the opposite, isn't it? One gets big, the other gets smaller. That's an inverse variation. So an inverse variation is going to be some number, xy equals some number. For us, in our little activity, we had x times y equals 24. This is an inverse variation equation because it was all the combinations of 24, but as one got big, the other got smaller, didn't it? 24 and 1. We could have gone 48 and 1/2. We didn't, but we could have, right? And we could have gone further and further, but as x got bigger and bigger, y got smaller. And then the opposite, when x was 1, y was 24, right? So as one got big, the other got smaller. What we saw then was we saw a graph that looked like this. If I just sketch this in, we saw a graph looked like this and like this. So that's the graph of an inverse variation. We also know that we'll have asymptotes at the x-axis and we'll have an asymptote at the y-axis, right? Now, the constant of variation is just simply that number. If we had x times y equals, we can call it c. In this case, our constant of variation was 24. Whatever number they multiply to make is the constant of variation. It's as easy as that. So if you see an equation that has an xy equals a number, it's an inverse variation. Yes, Ben?
Did my mom tell you that I couldn't sit with my friends?
Yes, we talked about that, yes. Okay. So now, if I were to take xy equals c and solve for y, then I would divide by x, and have x equals c over x. These are the same two equations. Or, if I divided and I solved, I'd have y equals 24 divided by x. These are the same two equations, aren't they? Same two equations. Now, can you divide by 0? Cooper, can you divide by 0?
No.
You can't divide by 0, can you? So one more time, x can't be 0 because if you divide by 0, and we're going to talk about that even more tomorrow, why you can't divide by 0. We're going to go into that. So you can't divide by 0, and that's why you have your asymptotes. Now, I want you to add something else. So now we're also going to talk about this thing called a direct variation. So this is not inverse, but this is direct. So this is like an example of as one thing gets big, so does the other. An example. If you plant a tree, as the years go on, as the years get more and more and more, the tree gets taller and taller. So as time gets bigger, the tree gets taller. People, as you grow older, you get taller. That's a direct variation.
I think we should do that with years.
So if we had y equals mx plus 0, that's a direct variation equation. Now, two things. Does this look familiar, first of all? It does, doesn't it? What kind of line is this?
Linear.
It's linear. Nice word. It is linear. It is linear, which we know in our vocabulary it means it's straight. Good word. So we know it's a straight line. What else do we know about this particular linear equation?
It starts at 0.
Yes. Yeah. Goes through the origin. So it must go through, must pass through the origin, which is the coordinate 0, 0. Good, nice word. I like that. Thank you, Cooper. So if we had y equals 3x as an example, That's direct variation. As x gets bigger, as x becomes 1, 2, 3, 4, y becomes 3, 6, 9. And it does start at 0, so this is definitely direct variation. This one's not. Not. Y equals 3x minus 1. This one's not because it doesn't go through the origin, okay? It has to go through the origin, right? So if it doesn't go through the origin, it's not a direct variation. And then one of the reasons we do that is because most experiments in physics start at time is 0, right? You throw a ball in the air. Time is 0, starts up and goes, right? All right? Now, let's turn the page. Ready to turn the page? Okay. So let's take a look at these. So if I take a look at number 1, I want to tell whether or not this thing's a direct variation, inverse variation, or neither. Okay? So if I look at question number 1, it's one of the three. This is either going to be direct, this one's either going to be inverse, or neither. I don't know. What do you think?
That looks direct to me.
Well, what if I divide by 3? Divide by 3, I get x, y equals 1/3. So I could go something times something equals 1/3. That looks like one of these equations, doesn't it? This would have been an x, y equals 24, right?
So is it direct?
It's going to be our inverse variation. So let's write these up here, up above, to help us out. So if we have x, y equals some constant, it's going to be an inverse variation. If we have y equals some mx plus 0, it's going to be a direct variation. And if it's neither one of these, then it's just neither. Okay, so we've got a little key above us. So how about number 2? What do you think on number 2? It's not in the right form, but we could fix it. It's not in the right form, but we could fix it.
Yeah.
Let's fix it.
Let's multiply by x.
Good job, Ben. So I'd have 5 equals xy. What do you think? Is it
I like that.
direct, inverse, or neither?
It's a
Direct.
direct. No, inverse. Inverse.
It's inverse, because two numbers multiplied to make, right, x times y, so it is inverse.
Babies, I love math.
You are awesome at it, okay? 3 is a little bit tricky, but what do I know about 3? What do I know about 3?
I think we should subtract x.
It's going to be neither.
It's going to be neither. It's going to be neither, because
Plus 11.
yeah, because we started at 11, we started at a height of 11, right? If I just do a real quick graph of this one, it's going to start up at 11, it's going to go up 1 over 1, it's like that. But it doesn't go through the origin, does it? Does not go through the origin. How about neither?
How about it?
Okay. How about 4? Okay. Okay, I heard neither. If I solve, we have y equals a negative x minus 2. So it's straight. It is a linear. Good word, Cooper. It is a linear function, but it does not go through the origin, does it? So
Is it a linear neither?
it's a neither. It's a linear neither. Okay, I'll go along with that. Sure, why not? How about 5?
Divided by x.
What if I rewrote it like this? Y equals 4/5 x.
Oh, then that is inverse. No, direct.
That's direct. Okay, it's direct. It has a slope. It does go through origin. You guys agree? Plus 0. So that's one's going to be direct variation. Am I going too fast? Am I going too fast? Am I okay? Okay, how about 6?
I think that is neither.
Yeah, if I solve for y, it's going to go through. It's going to go through actually negative 1/8, but this one's definitely neither. Nice job, Ben.
Gross equation.
Thanks, Ben.
Okay, am I going too fast? Slide it over for number 7. What do you think about 7?
That looks
Do you think if we multiply it by 7, that would help?
No.
X.
What if I wrote like this?
so it's not inverse.
It's not inverse.
So it's got to be direct.
It is direct because it has a slope.
Yeah.
It has a slope, and it goes through 0, doesn't it? Right? So this is going to be direct. Oh, number 8, the trick question.
Equals 0. Neither.
It's neither. Somebody could say that it could be inverse, divide by 6. But what times what makes 0?
0.
Well, and that
Anything.
but you're never going to get. Yeah, it's neither. It's neither. Number 9. What if I rewrote it as y equals 9x? What do you think? You okay with my fancy move there, bringing it on up? What do you think? Which one's this one? Sure looks like a slope to me. Direct. Now, how can you know if you get a bunch of numbers like 10, 11, 12? I didn't have enough time to go through this with my third period class, but I have time to go through it with you guys, okay? So, here's the key. Easiest one to find on these is inverse variation, okay? Let me show you why. If these two numbers multiply are the same as these two numbers, so if this times this is equal to this times this, which is equal to this times this, so x times y is always going to equal the same number. I'll say it again.
Is he here?
Yes, Chris.
Bruce.
So, here you go, Chris, and then I'll keep teaching, okay? So, guys, listen. What's 2 times 4? What's 2 times 4?
8.
4 times 16?
What are you doing, Chris? Good.
64. So it's definitely not inverse. It's not inverse. Because to be inverse, the two numbers, you have to have x times y equals some number, right? This one's definitely not inverse. Let's come back to it. How about this one? What's 1 times 5? What's 5 times 1? I don't know what 8 times 0.625, but if it's 5, I'm going to be happy, okay? So if I do this on my calculator, check it out. If I go, okay, 1 times 5, yeah, 5 times 1, yeah, 5. But what about 8 times 0.625? Oh. What about 20 times 0.25? Oh. And 50 times 0.1. So I know that x times y equals 5. So is this one an inverse variation?
It is so inverse.
You bet you it is, because if the two numbers multiply together make the same number, it definitely has to be inverse. Okay, now let's come back to 10. Let's look at 12. Okay, we're going to come back to 10. Okay, so let's check it out. Let's go 2 times 0.5. 2 times 0.5, I get 1. 5 times 1.25, I get 6.25. So this is not working for me, right? Okay, so this one's neither also. Now, it could be direct variation, okay? It could be. But to do it direct variation, I'm almost done. Let's think. Let's be smart about this. Okay, so to be direct variation, it's got to have a slope, right? You guys agree with that?
I agree with that.
So as y goes down by 4, x goes up by 4, right? As y goes down by point... Oh, gosh.
I am confused because I cannot see that.
There you go. It's my bad. My bad. Okay, what's 1 minus 0.625? 1 minus 0.625. 0.375. Okay, so as x goes up, does y go up by the same route? As x goes up, does y go up by the same amount? No, so this one's got to be neither. It's got to be neither. Neither, okay? This one's... Oh, you already got that one. Sorry, my bad. Okay, you ready? Should we do 10? I got distracted by the phone call. Goes up by 2, goes up by 2, goes up by 2, up by 2. What's this one? Go up by 12, up by 20, goes up by, I don't know, 28. This one is neither. Okay, now let's shift the page over to 13. Okay, 13 is super easy, okay? They want us to come up with an equation. So if we need an inverse variation, you ready? Want to see how easy this is? X times y equals some number, right? Okay, so I've got 2 times 2 equals what? So my equation is just simply x, y equals 4. Boy, we could do that so much faster, couldn't we? So tell me, what's the answer to 14? X
18.
times y equals 18. Done. Right? 15 is just a matter of doing fractions. X times y equals what? 7. Easy, isn't it? That's it. Now, I'm not giving you a lot of time to do the homework, but it's enough.